Okay, in today's lesson, I'm going to do examples on geometric sequences. So the first one is find the common ratio and write the next two terms. So for common ratio, we know that we need to divide the second term by first term and then third term by second term. And if you do that, you can see that the common ratio in this case is 2. So 5 over 2.5 and then 10 over 5. Both of it gives me 2, which means R in this case is 2. So for common ratio, we use R. So R is equal to 2. So once we know R is equal to 2, we can find the next two terms. So that will be here 20 and 40. So that is your next two terms here. Similarly, for the second one, you have R, which is equal to 3 over 9. And I can verify from 3 and 1 also. So R is equal to 3 over 9, 1 over 3, which means my this is same as 1/3. So R is 1 over 3, which means the next two terms in this case is going to be 1 over 3 and 1 over 9, because then you multiply 1 times 1 over 3 gives you 1 over 3. 1 over 3 multiplied by 1 over 3 gives you 1 over 9. Now here, to find the common ratio, do the same thing. 2x cubed divided by x, which is equal to 2x square. 4x raised to power 5 divided by 2x cubed. This is also 2x square. So common ratio in this case, R is 2x square. Now you multiply to find next two terms. You multiply this by 2x square, which is equal to 4 times 2 is 8, x to the power of 7. And then you do the same thing again. Multiply this by 2x square. So this is 16, x to the power of 9. The next one is we have 0.15, 0.45, 1.35, and 12.15. And in this question, you have to find the number of terms. So number of terms, the notation which we use for number of terms is n. So we need to find n in this case. And it's given that it's geometric sequence. So we already know this is GP. And from the sequence, we can find U1 is 0.15. And R can be found 0.45 divided by 0.15 or 1.35 divided by 0.545, and that will give you the common ratio. So when you divide this, your R in this case is going to be 3. So your common ratio is 3. So we already know R, we already know U1. So we know UN in this case is U1 R n minus 1. So 0.15, 3 to the power of n minus 1. And we have to find how many terms we have. So this is the first term. We know that this is U1. We can count it. This is U3, but we don't know which term is this. So I'm going to call this as UN. So I already know UN is 12.15. And now I can simplify. So 12.15 divided by 0.15 gives me 3 to the power of n minus 1. If you divide 12.15 by 0.15, you will get 83. So we can use calculator to do that. So 12.15 divided by 0.15, which is equal to 81. And 81 can be written as 3 to the power of, because 81 is divisible by 3, and same as 3 to the power of 4. And when the exponent is same, base has to be same, which means n is equal to 5. So these are 5 terms, so which means this is our 5th term. Okay, so the next one is, again you have to find here, in this case, the number of terms. So this one is U1, this is U2, this is U3. We don't know which one is that, so let's call it UN. And we need to see what kind of sequence it is. But this is the previous part, and it was given it's a geometric sequence here. So this is also GP. So U1 is 440, and I can find R by dividing 110 by 140. 440, 27.5 by 110. And if we divide this, we will get this as 1 over 4, which is 0.25. So R is equal to 0.25. Now this is UN. So UN is equal to U1 Rn minus 1. So 0.4296875. So 0.42 This is equal to 440, 0.25 n minus 1. Now you divide this number by 440 first, and when you divide, you use your calculator to do that. When you divide it, you will get, after doing all the calculations, your n will be equal to 6. Okay, so you can do this using your calculator, or I can show very quickly here. So if I go to alpha y, and if I enter 0.42968875 divide by 440, I got, okay, that's quite weird number here. Okay, so you can use calculator and see that what is the value of n you are going to get here. Okay, so the next one is, and if you do not get n is equal to 6, then there might be some problem in the statement. Okay, so the next one is the first term of geometric sequence is 4, and the common ratio is -2. So again, this is the geometric sequence, and the first term is 4, which means u1 is 4, and it's GP. And the common ratio is -2, so R is -2, and we have to determine which term has the value of -2048. So again, we don't know which term is this one is, so we will call this as UN. And we know the formula, which is U1 R n minus 1, so -2048 is equal to 4 times -2 to the power of n minus 1, and then you do the calculations here. So minus 2048 divided by 4 is equal to -512, which is -2 to the power of n minus 1. And now we need to express this as -2 to the power. And we know that 2 to the power of 5 is 32. And this is, I think, okay, so you express that, let's see, 2 to the power of 10. Okay, so this is 2 to the power of 9. Yeah, okay. So common ratio is this, yeah. So this is -2 to the power of 9. And then the basis is same, so n minus 1 is 9, so n is equal to 10. So this one is your 10th term. So this is U10. Okay. The next one. Okay. So the fourth term of a geometric sequence is 54. So I'm going to just underline, this is the fourth term, 54, geometric sequence. Sixth term, 486. And you have to find the possible values of the common ratio. So GP, fourth term, 54. Sixth term, 486. And you have to find the possible values of common ratio R. Now I know U4 means U1 R to the power of 3, which is 54. This is R to the power of 5, which is 486. Since this has more powers of R, so I'm going to rewrite and then divide in this order. U1 and U1 get cancelled, so R square, and 486 divided by 54 is equal to 9, which means R is equal to plus minus 3. So you can have a common ratio of 3 and -3. So in this, they ask the common ratio. So you can also underline the important things. So the first one, the geometric sequence 54, 6 term 486 was the given information. And the common ratio, determine the value of the common ratio. So there was only one thing which you needed to find, which was the common ratio. And you had GP given, you had fourth term given, sixth term given. So you can also use this technique to write down what is given and what are they asking you to find out in this case. Okay, so the last one in this one is the first term of a geometric sequence. Again, it's GP. So I already know this is GP. The first term, so the first term is 16, which means U1 is 16. And the common ratio, so we also know the common ratio is half, which means R is half. Find the biggest term. So we need to find the biggest term that is smaller than 1 over 1000. So which term is going to be? Find the biggest term. So the biggest one which is smaller than 1 over 1000. So I'm going to set up again. UN is U1 R raised to power n minus 1. And you have this as 16 1 over 2 to the power of n minus 1. And now we need to find the biggest term which is smaller than 1 over 1000. And 1 over 1000 is going to be 0.0001. So what we can do here is we can enter this into our calculator. I'm going to first clear. So this is 16. And then you have 1 divided by 2, which is 0.5 to the power of x minus 1. And now I'm going to set my table at 1. And now I'm going to see the values. So you can make this table and you can see, because we are looking for the biggest term that is smaller than 1 over 1000. So let's have a look at here. So keep on scrolling. So it seems like your 15th term is going to be, because if you change it, 9.8 e raised to power negative 4. So the 15th term is 9.8 e raised to power negative 4, which is same as 10 to the power of minus 4. So e in this in the calculator means 10. So if you see e raised to power minus 4, which means 10 to the power of negative 4. So if you simplify this thing, you will get 98 over 10, and then 1, 2, 3, 4 zeros, and then if you change it, this is the biggest term that is going to be smaller than 1 over 1000. Okay, that's it for today's lesson.